Welcome. So today I want to close out our discussion of Chapter 2 by looking at the concept of density. So density, something that a lot of you may have heard of, right, is the ratio of a substance mass to its volume, right? So how much mass does a given volume of a material have, in other words? Now, we've been talking about units here recently in the last couple sections, and so we're going to focus here on the units, right? So the units for density are typically grams per cubic centimeter or grams per milliliter. Now, cubic centimeters and milliliters are two common scales or two scales of volume that we use in chemistry. So there we can interchange these as a standard. Cubic centimeters are often used for solids, whereas milliliters are used for liquids. And so, but both of these units you'll see when we talk about the volume of a substance. So in an equation form, okay, density equals mass, or M, divided by V, divided by your volume. So this is going to be the key equation that we're going to work with when we work with density. So the units of density are an example of what we call a derived unit. And this is simply a combination of units. So when we were doing the sample problems, we saw one of these complex or derived units when we saw something like grams per pound, right? When we were looking at that last sample with the dosages, right? That's another example. Other common examples of these derived units are things like speed, right, where we have miles per hour, and volume, right, which, again, cubic centimeters, right? That's a more complex unit. And density, and it's just another example of these, what we call combination of units or derived units. So we talked a little about volume and before, and we worked with cubic centimeters. Now, I also said milliliters were very common, or the liter scale, or milliliters is the common way to express volume. Now, when working with density, the nice part is that 1 cubic centimeter equals 1 milliliter, right? So these units are completely interchangeable, right? I can simply change the unit and it doesn't affect the numeric value at all. So if I have 1,000 milliliters, that is also 1,000 cubic centimeters. Now, we also remember from our metric conversions, right, that we have milli here, and 1,000 milliliters would equal 1 liter. Or, if you want to think about it the way the table would have it, we would say that 1 milliliter would equal 1 times 10 to the minus third liters. Sorry. Now, if we look at the table over here, we have a list of densities. And I put this here just so we can talk a little bit more conceptually about what we mean when we say density. So again, it is how much mass is in a given volume of something. So that given volume is typically 1 cubic centimeter or 1 milliliter. And so by using this, a standard way to express them, we can easily compare densities. So for example, water has a density very close to 1 gram per cubic centimeter or 1 gram per milliliter. Whereas ethanol, right, is 0.789 grams per cubic centimeter. So it has a lower density, right? So the same volume is going to have a lower mass. Whereas other materials, such as, say, lead, aluminum, lots of metals, right, have densities that are much higher than this. So, for example, copper, 8.96 grams in every cubic centimeter or every milliliter. So if I have the same amount of water and copper, right, the copper is going to weigh almost 9 times as much. Right? So the same volume is going to be more massive. It has a higher density. So that's the idea. Now, density is what we will later call a physical property. And it's a physical property that can be used as a identifier of a material. So often the density is used to identify whether something is truly that material or not, or if it's pure. Right? Because if I have pure copper, it will always have a density of 8.96. If the density is something else, then it's not pure copper. Right? So it can be used as a identifier for a substance. So for example, if I have a ring that has a mass of 4.53 grams and a volume of 0.212 cubic centimeters, I want to say, is that ring really platinum, as somebody might be claiming? Well, the easy way to do that is to calculate the density. So I'm simply going to take 4.53 grams, and so my density, right, is going to equal my mass divided by my volume. So my volume here is 0.212 cubic centimeters. So if I do this, my calculator will tell me that I have 21.3679 grams per cubic centimeter. Now, we always want to think about significant figures. So if I look at my numbers here, this number has 3 significant figures. This number also has 3. So that means my answer can have 3. And so this would be 21, the 3, the 6 tells me to round it up, 21.4 grams per cubic centimeter. And if I go over here to look at platinum, I can see that this indeed is pure platinum. And so the ring is indeed pure platinum. So this is starting to work with density and how we can prove or use density to prove the identity of something. Now, another way that density is used is as a conversion factor. So what I mean by that is it's used to take the mass of some amount of substance and figure out how much volume it would occupy if we know the density. Or if I take the volume of a certain material and want to know how much its mass is going to be, I can use its density to do that. So it is often the way that we can, in the lab, know the mass of something, and if we know what the material is, we can figure out what the volume is going to be by using its density, or vice versa. So this is a really common technique in lab. We can measure either the mass or the volume and use the density of the material to calculate the other one. So it is the conversion, a way to convert between the mass of a substance and the volume of substance, or vice versa. So let's say we have a liquid here, and it has a density, a known density of 1.32 grams per cubic centimeter. And I want to know what volume should be measured to give me a mass of 68.4 grams. So we start to do some problem solving here. So if we think about what we're given, well, we're given the mass, and we're asked to find the volume. And so I want to start with the mass because that's what I know, and I want to get to the volume. Now, what's my pathway? Well, if I know that density is the conversion factor that allows me to go from knowing the mass to the volume, that's what's going to become my conversion factor. That's my pathway. So I'm going to start with what I know, 68.4 grams. And I'm going to use the density to get me into volume into cubic centimeters. So how do I use density as a conversion factor? So remember, when we have these complex units with units on the top and the bottom, what this really means is 1.32 grams per 1 cubic centimeter. So do I need the grams on top or the grams on bottom? Well, since I start with grams, I want grams on the bottom to cancel out and cubic centimeters on the top because that's what I want. So if I look at this, 1.32 grams. So remember, the number always stays with the unit on top, or the unit on top of stays with the unit on top of the conversion factor per 1 cubic centimeter. So my grams will cancel because I'm dividing them. So I'm going to be left with cubic centimeters, which is what I want. So if I do this, I get 51.8 cubic centimeters. Now, 3 significant figures is what I want in this because that's what I have in this final answer. So right, we have 3 sig figs here. Now again, the density, we also have 3 sig figs. And so we're going to express our answer in 3 sig figs. Now, density, while it is a conversion factor, it's probably not an exact number. So we probably should use the density to help us determine how many significant figures. And so since we're dividing 2 numbers here, we were going to use we would express it to whatever has the least. But since they both have 3, then we can express our answer to 3. Now, so 51.8 cubic centimeters is going to be my final answer. Now, this would also, remember, be equal to 51.8 milliliters if we wanted to express it in milliliters. So, remembering that 1 cubic centimeter, 1 milliliter, same thing. Okay, so density. This is going to become a really useful tool as we move through different areas of the course, and when we want to work with both mass and volume and go back and forth, right, we can use the density. So you're going to encounter 2 kinds of problems when you go through and do practice on these densities. We're going to have problems that were like what we did earlier, where we were just calculating the density. So using a mass and a volume to calculate the density. Or we're going to use the density combined with either the mass or the volume to figure out the other one. So remember, our equation is density equals mass over volume. So if we think about it, if we know 2 of these, right? So in this case, we knew the density and the mass, then we can figure out the third one. Right? So these problems are going to rely on us knowing 2 of these 3 values to figure out the missing one. So either we'll know the mass and the volume and figure out the density, or we'll know the density and either the mass or volume to figure out the other one. So this will get you some good practice on the algebra. So we need to make sure that we're comfortable working with solving for these different values based on, again, knowing whether we're going to divide by the density to get our grams to cancel out, or if we were trying to find the volume, if we were trying to find the mass, then we would have to multiply. But the key is, if you let the units guide you, then you won't run into any problems, right? So I know that I have to divide here because that's the only way that I can get my grams to cancel. And so use dimensional analysis, use the units to guide you, and you shouldn't run into any problems when you're trying to do these different types of problems. So that brings Chapter 2 to a conclusion. I want to remind you to be looking at the study guides as well. I would encourage you to use the study guides as you go through the notes, and either fill them out as maybe you listen to these videos or read through the printed PowerPoints that are available on Talon. And so use those PowerPoints that are on Talon, use the study guides as a way to, learn to become different methods to become familiar with the elements in the chapter. But use those study guides or fill those study guides out as you either read through the book, listen to these videos, and a combination of both.